For Algebra 2 at Trig, this is section 2.8. We're working with graphing linear inequalities with two variables. This is a single equation graphing on a coordinate plane. A linear inequality with two variables can be written as less than c, as less than or equal to c, as greater than c, greater than or equal to c. An ordered pair in the form of the x comma y is a solution of a linear inequality with two variables. So we're going to look at here and we're going to try to identify which of these coordinates will be a solution for this equation. So you take your coordinate, this is your x and your y, you plug it into your equation. So 5 times 5 minus 2 times 5 is less than or equal to 6. So we have 15 is less than or equal to 6. Well, that's not true. So we put a line through the inequality and say not a solution. We take our next point and we plug in our x and the y. And we're trying to see, is it equal to 6? Well, we know that 9 is not less than 6. So it's not less than or equal to, so not a solution. Now we're going to plug in 0, negative 3. Two negatives make a positive, and that is less than or equal to. In this case it's equal to, and that's fine. So we have our solution. And also if you plug in 3, 3, we get 15 minus 6. Again, we get 9. It is not a solution, so we draw a line through the inequality. So that's what it means when a coordinate point is a solution. It'll make the statement true. We got 3 false statements and we got a true statement. So 0, negative 3 would land in the shaded region of this inequality. Since it actually equaled it exactly, you would expect that it would land right on the line. The graph of a linear inequality with two variables is the set of all the points in a coordinate plane that represent solutions in the inequality. We have the shaded region, which is also considered to be a feasible region when we talk about that in a later section. The line that we draw in is called the boundary line. In some cases it'll be solid line, in other cases it will be a dashed line. The line that divides the plane, which is your xy axis, into two halves, one that's shaded and one that is not, is called a boundary line. Boundary lines can either be solid or shaded. Or dashed. A line cannot be shaded, but a line can be dashed. That means the points that land right on that line are not truly part of the solutions. If it was a solid line and it landed right on it, it would be truly a solution. A solid line, you're going to have inequalities that look like that with the line underneath it. A dashed boundary line is going to have symbols that look like that without the equal to line underneath it. Solid has a line underneath it. The dashed does not. So to graph a linear inequality, we're going to graph the boundary line and make sure that it's shaded, or solid actually, or dashed. And then one way you can do it, you can test a point to determine if what side of the boundary line should be shaded. I'll also show you how to look at the y-intercept to help you determine it, as long as it's in slope-intercept form. If the point is a solution, then then we will shade the half that contain. Shade the half plane containing the point. If the point is not a solution, when you plug the point in, a random point, back into the equation, and you don't get a solution, then we would shade in the other side of the half plane. So we'll try graphing. We're going to start out with x. This is x is less than or equal to 5. When it's an equation with one variable, any equation that says x is going to cross the x-axis. So similarly, if it was y, then it would cross the y-axis. So we write our equation, and we're going to shade less than that. So values that are less than 5 would be to the left. Now we have a y variable, only a y variable, so I know it's going to cross the y-axis. So we write out the equation. Y is greater than -2. So y is greater than, meaning it's going to shade above that. If you have both a y and an x, that's telling you that you're going to cross both the x and the y-axis. Here we look for it to be in slope-intercept form. Y equals mx plus b, and our b in this case is 0. So we have a y-intercept at 0 and a slope of -3. Down 3, positive 1. 1, 2, down 3, positive 1. Or you can go up 3, -1. Notice how it's a greater than, no line underneath it, just like our previous graph, so we make it dashed. From here we can test a point. You can pick any point as long as it's not on that dashed line. So I'm going to suggest to pick, let's pick 0.22. So I'm going to say that our x and our y value is 2, and our x value is 2. Is 2 greater than -6? That is a true statement, so we're going to shade in the area that includes that tested point. You can also go to the y-intercept. Y is greater than, so we go greater than the y-intercept, which would also include this portion of the graph. Here we have an equation written in standard form. We need to either graph it by intercepts, or we can graph it by converting it to y equals mx plus b. I'll convert it for you. When we divide by -2, we're going to switch the sign. 2 negatives make a positive. 2 negatives make a positive 3. Our slope is down 3, positive. Oh, it's a positive slope, so it's positive 3, positive 2. Or negative 3, negative 2. The line again is just greater than, so we're going to make it dashed. We need to write the equation. Y is less than 3/2 x plus 3. You can test the point 0, 0. When you plug in 0, you get 0 is less than. That would be less than 3, and that's a true statement. So wherever the 0 is located is the direction we need to shade. Or you can go to your y-intercept. The graph says less than, so you would go less than your y-intercept, which is all down below the graph. Now we have this absolute value. We're going to talk more in detail about graphing the absolute values at another time. So this is not needed right now. On the next page, we're going to have a story problem. You have 2 part-time summer jobs, one that pays $9 an hour and another that pays $12 an hour. You would like to make at least $240 a week. Write an inequality describing the possible amounts of time you can schedule at both jobs. How much time can you schedule at the $9 job? So x is going to equal the number of hours at the $9 per hour job. And y is going to be the number of hours at the $12 per hour job. So that's defining your variables. For us to write an inequality, $9 for the number of hours and $12 for the number of hours. Needs to be at least, meaning greater than or equal to 240. Now we can convert that in the slope inner form. Divide by 12. You're dividing by a positive, which gives you 20. 3 goes into both of these numbers. 3 goes into 3 3 times. 3 goes into 12 4 times. So we're going to start up at 20. Because both axes are going 5, 10, 15, 20, 25, 30, 35, 40, going by 5s. 5, 10, 15, 20, 25, 30, 35, 40. They're both going by the same amount. Then we can do our slope still down 3 over 4. That essentially is down 15 over 20. That's still a 3/4 slope. We like to write our equation. 9x plus 12y is greater than or equal to 240. And here we're going to graph greater than. You're going to graph above each of your points. This is an unbounded graph. It goes up forever. Next, we're going to do the same type of graphing, but now we're going to have a system. We're looking for where the shading happens for both of the graphs. What shading is in common? We're going to graph each inequality system, and we can use different colors to distinguish the different regions that we'll be shading in. We want to identify where the common, we're looking for the regions that are in common for the graphs of the inequalities. It'll be the portion that has every color that's being shaded. So we'll start out with our first equation. We'll start up at 1 and do our slope of 2. Y is less than. So we go down. We'll pick a different color. Start at -3. Have a slope of -1. This would be a solid line. This equation is y is less than or equal to -x minus 3, and we shade less than. So you go to your y-intercept and you go less than that, which is down. This equation was y is less than 2x plus 1. Its shading was down, so the common region is right through there. You want to make that considerably darker. We have our two equations. We're going to start at +1. do our slope of -3, +4, or +3, -4. That's going to be a solid line because we have the line underneath the inequality. Y is less than, so you go to your y-intercept, and less than that. For this graph, divide by 4, has a y-intercept of 4 and a slope of -3/4, +3, that would actually be dashed, this first equation was called y is less than or equal to -3/4 x plus 1. The second equation is y is greater than -3/4 x plus 4, greater than. So you go to the y-intercept and you go greater than that. So notice that these two graphs, the shaded regions, do not intersect. And this last example has an absolute value. We'll talk about that at a different time, so this is not needed.